All right, so recording. So the scoring guide says, hey, the primary purpose of this is to recognize a Bernoulli trial. And basically, that's basically a yes-no situation. And I would argue that the primary purpose is to give you a problem on a geometric binomial. Those are both examples of a Bernoulli trial, a yes-no situation. So in this case, an airline claims there's a 10% probability that a coach class ticket holder who flies frequently will be upgraded on any given flight. So that probability is a fixed probability. So either they're upgraded or they're not. So that makes this a yes-no situation. And it needs to be independent, and they tell us that. And then we need to make sure we can determine whether or not this is going to be a geometric or binomial. So it says, what's the probability that Sam's first upgrade will occur after the third flight? Well, it's a geometric distribution. You didn't need to write that. They wanted you to write it, but you didn't need to. It wasn't required. As a matter of fact, if you look at the scoring guideline and you look at the first responders' answers, they wrote very, very, very little. But they're saying the probability that it occur after the third flight. So in this particular instance, you have 0, 1, 2, 3, 4, ... all the way to infinity. And they're saying they want it to happen after the third flight, which means anything 4 or larger, 4 to infinity, would be acceptable. So basically, I'm sitting there going 1, 2, 3. I need 3 blanks, and what do you need to be in those blanks? Well, the probability that I'm not upgraded. Well, if the probability of an upgrade is 0.1, the probability of not upgraded is 0.9. And if I just multiply those out, I end up getting 0.729. So there's a 72.9% chance that Sam's flight was not upgraded during the first 3. Because all I did was probability of not upgrade times not upgrade times not upgrade. And that's the probability that it occurred sometime after the third flight. And really, you had almost no work to show on it, and they accepted it that way. The next one. What's the probability that Sam's will be upgraded exactly 2 times? So in this case, we don't have the keyword first. First kind of suggests a geometric. Exactly 2 means, hey, wait a second. We have a fixed number of successes and a fixed number of trials, and we have a fixed probability. That means I'm working with a binomial. So I should have written the formula, which is on the formula chart, and then I just need to plug in. And I want x equal to 2, and x represents the number of upgrades. I did not need to say that it was a binomial. As soon as I wrote the equation, that made it a binomial. So in this case, 20 choose 2, 0.1 squared, this is 1 minus the 0.9. 20 minus 2 gives me the 18. And if I were to go through the calculator on this one, I'd go second vars binomial PDF, and it's a PDF because it's exactly 2 times. So out of the 20 flights, 0, 1, 2, 3, all the way to 20, I only wanted 1 value. It was exactly 2. That means I'm working with a PDF. So trials is 20. My P in this case is 0.1. And my X value in this case is 2. All right, when I do that, I should get my value of 2.85 or 2.852. So there's about a 28.5% chance that Sam will have exactly 2 upgrades in there's 20 flights. Part C, Sam will take 104 flights next year. Would you be surprised if Sam receives more than 20? So if I make my number line 0, 1, 2, 3, 19, 20, 21, 22, all the way up to 104, I want the probability that X is greater than 20. So I'm looking for those values. Well, essentially, they're asking me to do a PDF of 21 plus a PDF of 22 plus a PDF of 23 all the way to PDF of 104. And I'd never get that done. So I need to look at doing a CDF because I have multiple values. So anytime I have multiple values, I'm going to think CDF. And I'm going to do 1 minus the binom CDF of 20. This does not need to be shown, and that will get you no credit. All right, that doesn't get you a credit by itself, but that's what we're going to plug into the calculator. All right, here's my work. 1 minus the probability of 0, a PDF of 0, and then all the values up to and including 20. All right, so here's the way it goes in the calculator. 1 minus second vars binomial CDF, trials in this case is 104. My p-value is 0.1. My x value in this case is 20. So 0.00136, which I rounded up to 0.0014. So the question asked me, would I be surprised? And the answer is, yeah, I'd be surprised. There's only a 0.0014 chance of it happening. So less than 1% chance that it's going to happen. So I'd be surprised if he had more than 20 upgrades. Now, had I wanted to for my work shown, instead of doing a 1 minus the PDFs, I could have done the PDF of 21 plus ... the PDF of 104. And that also would have sufficed for the answer. I would not be surprised to see, matter of fact, I would expect a binomial on this exam, even though it's a shortened exam. I would expect a binomial. I'd probably say there's about a 30% chance or a low chance that you'd have a geometric, but you could, certainly very fair, certainly doesn't take that long, but I would expect there to be a binomial. So that's something I would definitely spend some time studying. All right, I'm going to stop the recording so we can answer questions.